Okay, so new unit, new semester, new quarter, however you want to look at it. Moving forward, we're going to be spending some time using the Pythagorean Theorem. Now, we've used it a couple times, just a little bit, but we're going to really use it moving forward. So this is hopefully a little bit of a review. I know you guys have seen this before at some point, whether you've taken geometry before, or I know you might have used it in an algebra class because it is basically just an algebraic formula, and I want to show you how to use it. So there's really only one main thing you can do with the Pythagorean theorem. There's a couple little secondary things that you can do with it that we'll get into later, but like the biggie, the one thing you can do with the Pythagorean theorem is use it to find the missing side in a right triangle. So a right triangle has a right angle in it. So what you'll see in these pictures, somewhere you'll have an extra little box in the corner. That's telling you that's where your 90-degree angle's at. That's your right angle. And then kind of everything else that you need is based off of where that is at. You've got, you've got two shorter sides called the legs. They're usually going to be referred to as A or B. And then you've got the longest side, C, which is across from the right angle. That one is called, it has a special name, it's called the hypotenuse. That's kind of what that cartoon's about. If you bother to read that, they're just joking. It's a silly word, but hypotenuse. So the hypotenuse is the longest one. When you look at this Pythagorean theorem, and again, I'm sure you guys have heard this before. Some people get the Pythagorean theorem confused with the quadratic formula, just name-wise, but a squared plus b squared equals c squared is the Pythagorean theorem. What we're going to do is I'm going to give you two of those sides, and you're going to be asked to find the third one. Depending on which one is missing, whether it's a leg or whether it's the hypotenuse, is going to change how you set up your formula and how you have to evaluate it. So the easiest one is where you're missing the hypotenuse. The harder one, even though it's not really hard, it's just an extra step of arithmetic, is where you're missing a leg. Now, the A and B are interchangeable. When I set these up, I always set them up as if the A were missing just because of where it positions itself in the picture or in the formula in the equation, but it really doesn't matter. You need to be able to identify, just looking at this, you need to know, hey, this guy over here, that one's the hypotenuse because that's the important one. When you set up your equation, it's the one that's on the right-hand side of the equal sign by itself. The A and B, it doesn't really matter. Okay, so setting these things up. Oh, I forgot. I found this video. There's no sound or anything, so I'll talk over it. But what it's doing is it is literally creating an a square and a b square and a c square. It's just kind of a little video proof of how this thing works. So the area of the a side and the area of the b side equals the area of the c side. I just thought it was kind of neat. I forgot that was in there. All right, so really what I want to show you guys is just how to set these up and what I expect you to be able to do. Hopefully you have a calculator, either a calculator on your phone, which if you're doing that, you're going to want to turn your phone sideways so you can do the scientific calculator, or I would prefer it, honestly, if you had an honest-to-God calculator, but that's just my personal preference. So what I'm looking at here, I'm identifying my C first, so then these two guys are A and B either way. So I'm setting this up as A squared plus B squared equals C squared. Now, when you, if you haven't had me for algebra, you might be a little rusty with exponents, but you are squaring these things. You are not taking 33 times 2. You're taking 33 times 33. So the first thing you need to do is go through and evaluate your exponents. So x squared, I can't really do anything with. That's actually, that's going to come up here in a minute. But 33 squared is 1,089. I don't know that. I worked it out on a calculator. 55 squared is 3,025. And again, just the sheer size of these numbers, use a calculator, please, please, please. All right, so think back to algebra a little bit. And these aren't big, hard algebra problems, but I want to get the x by itself, so I need to get rid of the 1089. Now, you don't have to do all this work, pencil and paper. Use your calculator. 3,025 minus 1,089. that is 1,936. Okay, so that still equals x squared. Now, most equations that you probably did in algebra, you're solving for x, you're solving for x, you're solving for x, and you're done. This one has that one extra step because it's x squared. So what you'll need to find on your calculator, what you'll need to find on your calculator is the square root button, right? A square root undoes a squared operation. So when I take the square root of x squared, that's just going to spit out the x. When I take the square root of 1,936, that's 44. So my missing side up here is 44 yards. Okay. I'm not a real stickler on units. If the problem is given to you with yards as your unit, your answer is going to be yards. So you don't have to throw it in there. It really just kind of depends on the teacher. I don't particularly care. If you're using the calculator on your phone and you can't find the square root button, take a screenshot of your calculator and send it to me, and I'll help you out if you're remote, or just talk to me in class if you need help with that. So the second one is the same setup. Here's my right angle. So that's my C. X and 40 are my A and B. What I was saying earlier about always set it up as the A is missing, what I meant by that is I always put the X first if I'm missing a leg, even though it might not technically be the A, since A and B are switchable. It's okay. So X squared, I know 40 squared is 1,600. 85 squared I had to work out. That is a big one, 7,225. So when I subtract my 1,600, that is 5,625. Square root that guy. So X is 75. Now, they're not always going to be big answers like this, 75 meters. They're not always going to be big answers like this. As a matter of fact, the next two are much, much, much smaller. But, just trying to emphasize the use of a calculator here. Big numbers, use a calculator. Makes your life a whole lot easier. Okay, so on both of those, we were missing a leg. We were missing an A measurement or a B measurement. So what do you do differently if you're missing a C measurement, which is what these two are? And again, find your right angle. Across from that, this guy is your hypotenuse. All right, so the missing side is the hypotenuse. Same thing here if you want to look ahead at that one. Okay, that's your C. So all that means is when you set this up in your A squared plus B squared equals C squared, your variable is going to be over here by itself instead of the two that are together. So when I set this one up, 9 squared plus 12 squared equals x squared or c squared, or your variable, whatever you want to use there. What's different about these is because the variable isn't mixed up with those guys, you don't have to do that little subtraction step where you take something to the right-hand side of the equal sign. So 81 and 144 for those guys. 81 and 144 is 225. And then again, you're going to have to take the square root. All of these, every single one, when you're doing a Pythagorean theorem problem where you're trying to find a missing side, your last step is to take the square root. So that is 15 for that guy. Same thing here, 3 squared plus 4 squared. That's your x squared. Sorry, I got sloppy there. 9 and 16. That's 25. Right, much smaller answers on these, but again, you still need to take the square root at the end. These will not always work out to be whole numbers. I'm just kind of easing you guys into this. I picked specific ones where your answers were whole numbers. We'll get into the decimals and how all that works out tomorrow.